Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
So friends, now we are going to talk about what is atomic radius and what are the factors that will affect the atomic radius when we are looking in a periodic table. So there are many factors that would affect the atomic radius of a particular element when we are looking through a group or when we are going through a period. So as we know that the atomic size changes, and this is known as basically the trend, the periodic trend of a property that we are going to talk about. So what is that kind of trend, or what are the factors that will affect that? Let us talk about it. So now we are going to talk about what is atomic radius. So the distance between the central nucleus of an atom and the valence shell of an atom that consists of an electron is known to be the atomic size, or known as atomic radius. So let me give you a short glimpse of it. As you know that the atoms is been composed with the nucleus and it has multiple shells around it. So this nucleus, the distance between the nucleus and the outermost shell, as we could see, the outermost shell or the valence shell, as we could say, the valence shell that consists of an electron. So the distance between the nucleus and this electron is said to be atomic size, or basically known as atomic radius. As you could see that this is nothing but the radius of this spherical atom. So usually what happens is we measure the radius of a particular unit in terms of picometer, that is pm. So the size of an atom is very much small, and because of which we are usually denoting it by atomic size. Whenever we say atomic size, it will represent the atomic radius only, because atomic radius and atomic size, the both are same. So therefore this is the central nucleus of an atom, and which has a valence shell. This is the first shell, second, and this is the outermost shell, or we could say it as the valence shell, which consists of an electron. Suppose if this would have not consist of an electron, but now in this case what happens is this would be the valence shell which will contain an electron. So that's the reason there is a difference in what we are talking about when we say that when we are talking about the valence shell, and that valence shell should consist of an electron, then only that would be said to be an atomic size of that particular atom. So now we are going to talk about that what are the factors that will affect the atomic size of the atom. But before that, let me talk about what is ionic size also, because even we are talking about when we are talking about atomic size, we are also talking about ionic size also. So in this case, what is ion actually? Ions are basically divided into two types, that is, one is cation and one is anion, as you know. So in this cation and in this anion, the difference is, when it comes to cation consists of a positive charge, or we could say that it contains less electron compared to that of their parent atom. So because of which what happens is the number of charge increases, the positive charge, number of positive charge increases, and therefore it becomes it has a positive charge. While that of the anion, it consists of extra electrons, or that's the reason it has a negative charge. And moreover, talking about the size of it, that we are going to talk right now, that is the factors that would affect the atomic size, and by which we would also come to this point that what will be the effect, or what will be the size of the cation compared to that of the parent atom. That is also we are going to talk about. So before understanding that what are the factors that affect the atomic size, let me tell you a few things. So now talking about what are the factors that will affect the atomic size. Among that, the first factor is basically number of shells. The number of shell plays a very important role in deciding what would be the atomic size of a particular atom. For example, if the number of shell increases, then what we are going to say is, if number of shell increases, then the atomic size will also increase. Therefore, it is said to be that the atomic size is directly proportional to the number of shell. How? For example, if I talk about the element like lithium. So when it comes to lithium, then lithium has basically two shells in its atom. So therefore, I could write the lithium as which has a particular nucleus and having two nucleus, where two electrons are being located here, while this is the third electron. But when it comes to sodium, so sodium can be written as, because it consists of three shells, as we know. So therefore sodium, in this case, suppose if this is the nucleus of it, so the first will contain two electrons, while the second will overall contains basically 8 electrons, and the last one, that is the third shell, it will consist of basically 1 electron. So in this case, what affects an atomic radius is, the atomic radius is affected by the number of shells. So therefore, as we know that now in this case, the atomic size would be nothing but the distance between the nucleus, as you could see, or the central nucleus, and the electron which is present in the outermost orbit, or which is present in the valence. So now when we are talking about sodium, sodium consists of 11 electrons. That is the reason the atomic number of sodium is 11. So it consists of 11 electrons, in which the first shell consists of 2 electrons, while the second shell will overall consist of 8 electrons, and the third shell will consist of only 1 electron. So when we are talking about the atomic size is nothing but the distance between the nucleus, the central nucleus, and the outermost shell consisting of an electron. So this is the valence shell of the outermost shell that we can observe here. And in this case, since the number of electrons along with that, the number of shells are being more, because of which the atomic size is more compared to that of the lithium that we have, because this consists of only 2 electrons, only 2 shells and 3 electrons. So therefore, this makes us to know that the factor that will affect the atomic size is nothing but the number of shell. If the number of shell increases, then obviously that the atomic size will also increase. So this was the first factor. Then what we have talked about, the factors that would affect the atomic radius. So now let us move to the second one. The second one is nothing but nuclear charge. So basically there are 3 factors, in which the first factor was the number of shell, the second factor was nothing but the nuclear charge. And what is actually nuclear charge and how does it affect? Let me talk about that also. So nuclear charge is nothing but the attraction, the force of attraction between the nucleus and the outermost electron present in an atom. That's the reason they hold the outermost electron in an atom. So this kind of force of attraction between the nucleus of an atom to the outermost electron of the same atom is nothing but known as the nuclear charge, because nucleus consists of protons and neutrons, and protons are usually positive charge, while electrons are basically negative charge. So therefore there will be a force of attraction, but they have a particular criteria, and the criteria is the tendency to hold the outermost electron is nothing known as nuclear charge. So how does the nuclear charge plays a very vital role in affecting the atomic size? Let me talk about that also. So, but the nuclear charge have few conditions. As you know, that nuclear charge depends on the attraction of the nucleus with the outermost electron. So the attraction will be more when the atomic size will be less. So that is what I am going to talk about. That is, when it comes to nuclear charge is actually inversely proportional to atomic size. How? Again, I will give you an example. So suppose in this case, suppose in lithium, if I have given an example. So this was the first factor that was affecting the atomic size. So in this case, as you could see, that the lithium has only 2 shells, and moreover the nucleus is very much close towards the third electron, or you could say it as the outermost electron. So because of which, because the distance is very much less, or the atomic radius is very much less, so because of which the protons, or there will be force of attraction between the positive charge and the electron, and that will result in the higher nuclear charge in lithium in this case compared to that of the sodium that we earlier had. Taken an example. So therefore, the sodium, which has now 3 shells, as you could see, because of which the distance between the nucleus and the outermost electron it increases, and what happens is the attraction of the nucleus, which consists of protons, with the outermost electron, it will get reduced because the distance goes on increasing. and the distance goes on increasing, then what will happen? Obviously, the force of attraction will be less. And because of which, what happens is, in this case, in the sodium, when we are talking about sodium as a parent atom, not as an ion. So sodium atom basically has less nuclear charge compared to that of the lithium. So that's the reason the atomic size is less in that of the lithium and it's more in that of the sodium. So we could say in this manner also that if the atomic size is less for a particular element, then that makes a surety that the nuclear charge will be more in that case. And if an atomic size is more, then it says that that the nuclear charge will be less, because of which the atomic size is more. So therefore, the second factor that we have got to know is nuclear charge, and this is what we have got to know, that nuclear charge is inversely proportional to the atomic size, and because of which it plays a very influential role in the factor that affects the atomic size. So talking about the next one, the next is nothing but screening effect. Screening effect. So what is actually screening effect? Let me tell you that also. Talking about the sodium, because sodium is one that I'm going to talk about. So again, sodium consists of basically three main shells. The first one consists of 2 electrons. The overall second shell consists of 8 electrons. So this is, there will be 8 electrons as I will draw here. And ultimately 1 electron in the outermost shell. So what is actually screening effect? As you know that when it comes to an atomic size, or whenever a shell is being represented, it can be represented by the number of orbitals also. So what are the number of orbitals and what are number of orbitals? It is basically denoted by S, P, D, F, as you know. So S orbital, P orbital, D orbital and F orbitals are the subshells of a particular main shell. So in which what happens is, since the nuclear charge is nothing but it is the attraction of the nucleus with the outermost electron. But as you can see, there are inner electrons also. So this inner electrons means this inner 8 electrons, as I would mention here, and this inner 2 electrons, and they are present in this case. So what will happen? They will resist, or they will make a screen so as to lower the attraction of the nucleus with the outermost electron. So because they are shielding it, or they are preventing the force of attraction of this nucleus with the outermost electron, this kind of effect that are shown by the inner electrons of an atom is nothing known as screening effect. So therefore, how the screening effect will be more or will be the less? As you know that if the number of shells increases, or if we could indirectly say that if the atomic size increases, obviously that the inner electrons will be more. And if inner electrons will be more, then what will happen? Because the nucleus will have no that much attraction to the outermost electron when it comes to the size. So the size is more, then the nuclear charge will be less. So what happens is this inner electrons resist the force of attraction between the nucleus and the outermost electron. And moreover, this thing is known as screening effect. And talking about the orbitals, we have S, P, D and F orbitals, in which it has been known that S orbitals are the orbitals that contains 2 electrons that will prevent, or that will have more screening effect, while that of P, while that of D and F. So this kind of resistance of the inner electrons so as to attract the outermost electron from the nucleus is known as the screening effect, and this plays a very vital role, because if the screening effect is more, what will happen? The nuclear charge will be very much less, and because of which the atomic size will be more. And when we are talking about if the screening effect is less, what happens is the attraction between the nucleus and the outermost electron will be more, and because of which the atom gets shrinks, or we could say the atomic size reduces, and that plays a very effective role in the factor affecting atomic radius. So this was based on the atomic radius, but based on this thing we can also predict that what would be the factors affecting the ionic radius and what are those. Let me talk about that also. So as I mentioned earlier that a particular ion is being divided into cation and anion. So what will happen to the cation size and what will happen to the anion size? So let us talk about the first one, that is when we are talking about a cation size. So how is a cation being formed? A cation is formed by removing its outermost electrons. For example, I will take the example of sodium like earlier. For example, if I have a sodium, and in this case, if I have removed an electron, this would be in gaseous state. So, if I remove the electron, then this would be turned into Na plus, while electron will be removed. So, this electron will be removed from the outermost shell. So, what will happen actually? Earlier, what we have got to know that this sodium, which has an outermost shell and which consists of one electron, and while converting this sodium into a sodium ion, so what happens is this electron gets eliminated and overall the number of shell will be reduced. So the number of shell will be now 2, earlier it was 3. So now what happens, if the electron is being removed from the outermost shell, then the number of shell now here is left 2. So since the number of shell is left 2, so therefore what will happen is the distance between the nucleus and the outermost shell that contains electron will be this one, not the above. So now this is the ionic radius that we are talking about. So this makes to understand that sodium as a parent atom will have more atomic size compared to that of the cation of sodium, that is known as Na+. So this shows that when it comes to atomic size, so atomic size of an atom, suppose if I am saying like for sodium, will be greater than that of the sodium ion, that is known as ionic size, or in this case cationic size. So this is what it is. And now talking about the next one, that is what will happen to the anion. Talking about anion, anion is nothing but a particular atom that consists of an electron, that consists of an extra electron. For example, if I would talk in this way, suppose if chlorine, if I am talking about chlorine as a gaseous atom, and in case if I have added an electron, so what will happen, this chlorine will consist of a negative, extra negative charge in this case. So this will now become basically a negative charged atom, which is basically known as an anion. So what will happen to the atom, what will happen to the anionic size of this thing? Because chlorine consists of basically 17 electrons, so we could write it in this manner also, or I could make you understand in this way. Yes, again, this will have multiple shells around it. For suppose if this is for chlorine atom, and what if I have added an electron, as I have said here also, if I have added an electron. So suppose if this extra electron that I have added here, so what will happen to this? This is not an atom right now, this is now an anion. So earlier what happens is whenever the extra electron was not here, so what will happen? The nuclear charge will be the same. But what happens when this electron enters? When this electron enters, it will play a repulsion between the other electrons also that are present in this shell or that are present in the inner shell. So what will happen? This will create a repulsion, because of which the nuclear charge that was earlier was more, but now in this case what happens? It will become less. And the effective nuclear charge, if it becomes less, then what happens? This is what we have told earlier also, that if the nuclear charge is less, then the atomic size will be more. So therefore what happens in this case is, if the nuclear charge is less, so therefore the size of this chlorine anion will be more. So that makes us to know that when it comes to an anion, so anionic size is very much is greater than that of the atomic size, for which we have a detail, like for fluorine what we have. For fluorine, when we are talking about fluorine as an atom and fluorine as a negative charge. So fluorine as an atom has an atomic size of 64 picometer, while that of the fluorine anion, which has basically 136 picometer. So this plays a very great difference in knowing that Fluorine, which has a negative charge, is having a more more size, that is 136 picometer. And when it comes to the cationic size, that is when we are talking about sodium. So atomic size of sodium, it has been found to be basically 186, by that of Na plus ion, that is the sodium ion, it is being found to be 95 picometer. So by this thing we have also got to know that is what is cationic size and what is anionic size. So thank you friends for watching this video. I hope you have understood that what is atomic size and what are the factors that will affect the atomic size, as well as when we have also talked about what great influence that it takes place when it comes to anionic size as well as a cationic size of a particular atom. So thank you friends for watching this video. I hope you have liked this video and will share this video with your friends and will learn more and more. So don't forget to subscribe to Ekeeda channel. Thank you so much.